Have you ever stopped to wonder what's really going on when you ask an AI something? You know, it feels like pure magic, but it's not. It's actually a stack of some seriously powerful technology. So today, that's exactly what we're going to do. We're going to peel back every single layer, from the app on your screen to the silicon deep in a data center. Let's get into it.
It all starts with something super simple, right? A basic thought, a question. Finds me the best flights and hotels for a trip to Paris next month. You type it in, you hit enter, and boom. In just a few seconds, a whole itinerary pops up. It feels completely effortless. But seriously, how does it actually do that? I mean, how does it get what you mean, sort through basically infinite options online, and come back with the perfect answer, just for you, in seconds? It's not magic, but it is absolutely brilliant. Well, the secret is in something called the Gen AI stack. And probably the easiest way to think about it is like a high-tech layer cake. Each layer has a very specific job to do, but the real magic only happens when they're all working together perfectly. So let's cut ourselves a slice and see what's inside, starting from the very top.
All right, let's start at the top layer, the one that we all see and interact with every single day, the AI agents. This is the part of the operation that you can actually see and talk to. So, what is an agent exactly? Well, think of it as a piece of software that's on a mission. And that mission could be anything, from planning your vacation to summarizing a long, boring report. Its whole job is to observe what's going on, use the tools it's been given, and get that goal accomplished. It's pretty much the AI's hands and eyes in our digital world.
But not all agents are created equal. They usually fall into one of two big categories. First, you've got your conversational agents. These are the chatbots we all know, the ones that can write a poem or help you brainstorm ideas. They're built to understand all the nuances of human conversation. And then you have workflow agents. These guys are the real workhorses, designed to do complex, repetitive tasks, like processing thousands of invoices without making a single mistake.
So how does one of these conversational agents, like our Paris trip planner, actually work? Well, it's a pretty elegant little loop. First, you give it some input. Then it uses its AI brain to figure out what you really mean, your intent. After that, it might call on a specific tool, like a search engine or a flight database, to get the info it needs. Then it cooks up a natural-sounding response and delivers it right back to you. It looks simple on the surface, but trust me, what's happening underneath is incredibly complex.
Okay, so the agent is the face of the operation. But every face needs a brain, right? So where does all that intelligence come from? Well, for that, we need to peel back the next layer and meet the real brains of the outfit, the AI models and the platforms they live on.
The AI model is the brain. It's this huge, complex web of mathematical connections that's been trained on an absolutely staggering amount of data. I'm talking more information than any person could read in 1,000 lifetimes. And by sifting through all of that, it learns the patterns of language, logic, and even creativity.
But here's the really cool part. You don't have to build these massive brains from scratch every time. That would be like trying to build a new car engine just to go to the grocery store. Instead, developers can go to a model hub, which is basically a library of powerful, pre-trained models. A great example of this is the Model Garden on Vertex AI. It's a central spot to find, tweak, and use the perfect AI brain for whatever you're trying to build. And the selection you have is just wow. I mean, in a place like Model Garden, you're looking at more than 160 different specialized models. That's a whole library of AI brains, just sitting there ready to be put to work. It gives developers a huge head start.
Now, what's really crucial here is the flexibility. A developer isn't locked into just one kind of model. They can pick and choose. They can use cutting-edge models like Google's Gemini, or they can leverage fantastic open-source models like Llama, or even bring in specialized models from other companies. It's all about using the right brain for the right job. Of course, all these models need a place to live, a place to actually do their work. And that's the job of the platform. Think of Vertex AI as the workshop. It's the one place that brings together all the models, all the data, and all the tools you need to actually build and manage your AI applications. But a platform is way more than just a library. You need a serious set of tools to manage these models. And that's where something called MLOps, or machine learning operations, comes in. Think of it as mission control for your AI. It handles everything from building and testing to deploying and monitoring, making sure the model works reliably day in and day out. This is what turns a cool experiment into a professional, enterprise-grade solution.
So, we've seen the agent and the brain. But what's powering it all? What's holding this entire structure up?
To see that, we've got to go down to the deepest layer, the foundational infrastructure. This is where the raw power comes from.
Welcome to the engine room. Seriously, the infrastructure layer is where the digital world becomes physical. We're talking about massive racks of servers, miles and miles of fiber optic cables, and specialized silicon chips all working together perfectly. This is what provides the raw, brute force muscle needed to train and run these gigantic AI models. In this whole engine room stands on three critical pillars. First, there's high-performance computing, specialized processors like GPUs and TPUs that can do trillions of calculations every second. Second, you need high-performance storage that can feed those processors massive amounts of data without any slowdowns. And finally, you need super-fast networking that can tie thousands of these chips together so they can act like one giant supercomputer. Okay, so far everything we've talked about lives in the cloud, powered by these huge data centers. But that's not the only way it works. Let's look at a really fascinating twist on all this, taking AI to the edge. Just think about a self-driving car for a second. It sees an obstacle. It has to react in milliseconds. It absolutely cannot afford the delay of sending data to the cloud and waiting for instructions to come back. The decision has to happen right there, inside the car. The same thing goes for your phone when you're on a plane or somewhere with no cell service. And that's exactly where edge computing comes in. The idea is actually really simple, but also really powerful. Instead of doing all the thinking in a faraway data center, you run the AI model directly on the device itself. You bring the computation as close as possible to where the data is being created. So why do this? Well, there are three huge advantages. First off, speed. You get practically instant responses because there's no delay. Second, privacy. Your sensitive information, like your photos or private messages, never even has to leave your device. And third, it's just reliable. Your AI will work perfectly fine even if you're completely offline.
Now, doing this requires specially designed models. You can't just cram a massive data center model onto a smartphone. It just won't work. That's why we have models like Google's Gemini Nano. It's a super efficient, compact version of its bigger siblings, built from the ground up to run powerful AI tasks right on your phone.
So there you have it, the full stack. We've gone from the conversational agent you talk to, down through the AI brain and the platform that manages it, all the way to the raw hardware of the infrastructure at the very bottom. Each layer is its own complex world, but they are all totally interconnected, working together to get you one simple answer to your question.
And understanding this stack isn't just a fun tech deep dive. It's really a blueprint for creation. It shows you the actual building blocks for the next wave of technology. So the only question left to ask is, what are you going to build with them? Thanks so much for tuning in. See you next time.